Hi everybody. In session we covered how to calculate a prevalence. So we said that we could calculate the proportion of people in the Framingham Heart Study that were male, the prevalence of male sex in the Framingham Heart Study. And we also looked at different prevalences of coronary heart disease. Today what I'd like to do is show you how to use Stata to calculate a prevalence. I'm also going to show you how to restrict your analysis to non-missing data. And we're also going to discuss how to calculate a cross-classification of two variables using a 2x2 table. So we're going to do this by calculating the prevalence of smoking in the Framingham dataset. So let's get started. The first thing we want to do is calculate the proportion of people at each visit that report current smoking. So let's go ahead into Stata. We're going to open up our dataset. And then we can go to Statistics, Summary Tables and Tests, Tables, Multiple one-way tables. So our categorical variable here is going to be the curse smoke variable. We have curse smoke 1, 2, and 3 for the different visits. And for each visit, curse smoke is recorded as 1 if you are a current smoker, and curse smoke is recorded as 0 if you're not a current smoker. So in this categorical variable field, we can use the drop-down to select these variables, or we can just type them in. Another option is a shortcut in Stata, and you can just write curse smoke with an asterisk. And that will ask Stata to generate these tables for all variables starting with the word curse smoke. We're going to check the box to treat missing values like all other values, and hit OK. The first thing you can see is that Stata will provide syntax based on our drop-down options. So in the future, if you like, you can just type in this syntax to get the same results. So as we can see, for the first visit, 2,181 of the 4,434 participants reported that they were smokers, resulting in a prevalence of 49%. For the second visit, 1,727 of our 4,434 participants reported smoking, resulting in a prevalence of 39%. And finally, for our third visit, we had 1,121 reporting smoking, resulting in a prevalence of 25%. Another thing to notice here is that we have missing data, shown with a period. For visit 2, there's 504 people missing smoking status, and for visit 3, there's 1,171 missing smoking status. But overall, we can see that the prevalence is declining from 49% at visit 1 to 39% at visit 2, down to 26% at visit 3. But because of this missing data, what we'd like to do is see what would happen if we looked at the prevalence only among people who had available data at each visit. So let's go ahead and repeat this analysis, calculating the proportion of people at each visit that report current smoking among those with data on smoking status at that visit. When we go back to Stata, we can once again go to Statistics, Summary Tables and Tests, Tables, Multiple one-way tables, and you'll see that your variables from your last analysis are still written into the syntax, into the windows here. But now what we can do is uncheck that box to treat missing values like all other values. What we see here is that the missing data is no longer shown. So the prevalence drops from 49% at visit 1 to 44% at visit 2, down to 34% at visit 3. Another option for restricting to non-missing data would be to calculate the proportion of people at each visit that report current smoking among people who have data for all visits. In order to do that in Stata, what we have to do is create a new variable to indicate whether a person has data for all visits. In Stata, missing data is counted as infinity. So if a value is less than infinity, it's not missing. So let's go ahead and create this new variable. So I've created a new variable called curse smoke not miss. And in this variable, if a person has all values less than infinity, i.e. not missing, then curse smoke not miss will be equal to true and will be recorded as 1. On the other hand, if a person is missing data for one of those points, curse smoke not miss will be equal to false and it'll be recorded as 0. So then we can go ahead And once again, hit Statistics, Summary Tables and Tests, Tables, Multiple One-Way Tables. And once again, we're using the cur/smoke variables. We're going to select the tab for by, if, or in, and we're going to say to restrict all of our analyses to observations where cur/smoke not miss is equal to true, or recorded as 1. And as Lauren showed you in a previous session, when we're doing one of these equality tests, we always have to put 2 equal signs here. So as we can see, now all of our results are restricted to the 3,206 people who had data at all 3 time points. And we see that once again, the prevalence of smoking is declining over time. At visit 1, it was 48%. At visit 2, it was 44%. And at visit 3, it was down to 34%. There's several possibilities for why the prevalence of smoking is declining over time. One reason may be that people are quitting. So at visit 1, they're smokers, but by visits 2 and 3, they're no longer smokers. Another option is that smoking affects your survival, and therefore smokers are not available to participate for visits 2 and 3 because they did not survive long enough. A final option may be that people who are smokers just decide not to participate in subsequent visits even though they're alive. So the next thing we'd like to do is evaluate whether perhaps the reason why the prevalence of smoking is declining over time is because there's a change in smoking status between visits 1 and 2. So we're going to go into Stata and create a 2x2 table to cross-classify smoking status at visit 1 and smoking status at visit 2. So in Stata, we're going to hit Statistics, Summary Tables and Tests, Tables, and now we're going to hit two-way tables with measures of association. Our row variable is going to be smoking status at visit 1, and our column variable is going to be current smoking status at visit 2. We're going to ask Stata to show us the missing data, and we're also going to ask Stata to report relative frequencies, because this will help us familiarize ourselves with the data. So as you can see, Stata provides a lot of information just for these 2 variables. And it's really great whenever you're doing any epidemiologic analysis to just get a sense of who's in your study and some of the basic relationships by using some of these relative frequency commands. So over here you can see our classic 2x2 table, where we have a binary variable as our row. Here it's going to be smoking status at visit 1, and a binary variable as our column variable, which is smoking status at visit 2. And you'll recall from our previous analysis that we had 504 people with missing data on smoking status at visit 2. But we'll get back to that soon. For now, let's just focus on the different values that Stata will provide. For now, let's focus on this bottom right cell. What we're told here first is the frequency. We're told that there's 1,596 people who were smokers at visit 1 and smokers at visit 2. The next value that Stata provides is a row percentage. And that's saying that among our total number of people who were smokers at visit 1, so among the 2,181 people who were smokers at visit 1, 1,596 of them were smokers at visit 2. So if we do the 1,596 divided by the 2,181, our row percentage would be 73%. The next thing that Stata provides is a column percentage. So now we're going to look among our total column. Among the 1,727 people who were smokers at visit 2, 1,596 of them were smokers at visit 1. So our column percentage is 92%. And finally, Stata provides a cell percentage. Among the total 4,434 people in our study, 1,596 of them were smokers at both visit 1 and at visit 2. So if we do our 1,596 divided by the total of 4,434, we'll get a cell percentage of 36%. But let's think a moment now about this missing data that we've observed before. We noticed that we had 504 people who were missing data on smoking status at visit 2. And what you'll see here is that 44% of that missing data, so again, from the 504, our column percentage was 44%. So 44% of the people missing data at visit 2 were not smokers at visit 1. On the other hand, 56% of the people who were smokers at visit 1 do not have information on smoking status at visit 2. So perhaps there's something going on here. Maybe the reason why we have more missing data for people who were smokers at visit 1 is because these are the people who either were not alive to participate in visit 2 or they chose not to participate in visit 2. So let's repeat this analysis, only now let's look at this cross-classification of smoking status at visit 1 and visit 2, but only among those who have data for both visits. So we can go to Statistics, Summary Tables and Tests, Tables, 2A tables with measures of association. And now we're going to deselect the box for treat missing values like other values. Okay, as we can see here, it's our same values where we have 1,898 people who were not smokers at visit 1 or at visit 2, 1,596 people who were smokers at both at visit 1 and at visit 2, and then we have the people who changed smoking status. There were 131 people who were not smokers at visit 1, but they became smokers by visit 2. So 3% of our total population became smokers. On the other hand, there were 305 people who were smokers at visit 1, but they quit and they're no longer smokers by visit 2. And that's 8% of our total population. So this may suggest that we have more people who are quitting smoking over time, and perhaps that explains why the prevalence of smoking is changing over time. So in conclusion, we saw that smoking prevalence declined over time in the Framingham Heart Study dataset. We suggested several different possibilities for why this may have occurred. It's possible that smokers are quitting. It's possible that smokers have a shorter life, and therefore they're not surviving long enough to participate in subsequent visits. Or it's possible that the reason why we have a prevalence declining over time is because they're less likely to participate even though they did survive. Finally, we used Stata to show you how to calculate a prevalence. We looked at how you can restrict your analysis to non-missing data, either for that one visit or for all visits. And we used a 2x2 table to cross-classify two different variables. See you next time.